Evaluate integral 0 to pi by 2 sin x upon 1 plus cos square x dx. So let us substitute. Put cos x is equal to t. So differentiating with respect to 2x, we'll get minus sin x dx is equal to dt. So we can write sin x dx is equal to negative of dt. So we can substitute sin x dx is negative dt, and also we need to change the limits. When x is equal to 0, t is equal to cos x, that is cos 0 is 1, and when x is equal to pi by 2, t is equal to cos pi by 2, which is 0. So we can write the integral. When x is 0, we can say 1, and when x is pi by 2, it is 0. 1 to 0. Sin x dx is minus dt upon 1 plus t square. Let us change the limits. So instead of 1 to 0, we can write 0 to 1 by changing the sign. Negative of negative dt upon 1 plus t square 0 to 1. Or we can write integral 0 to 1 dt upon 1 plus t square. We know integration 1 upon 1 plus x square is tan inverse x. So we can write tan inverse of t plus, and here the limits are 0 to 1. So we can write is equal to upper limit tan inverse of 1 minus lower limit tan inverse of 0. So tan inverse of 1 is pi by 4 and tan inverse of 0 is 0. So we can give the answer pi by 4. So you can go with an option B, pi by 4. Evaluate integral under root of x upon 4 minus x power 3. So we can write root x upon under root of 4 minus x power 3. So this can also be written integral x to the power 1 by 2 divided by under root of 4 we can write 2 square minus x we can write x to the power of 3 by 2 whole square dx. And let us substitute or put x to the power of 3 by 2 is equal to t. So differentiating, we'll get 3 by 2 into x to the power of 1 by 2 dx is equal to dt. That is x to the power of 1 by 2 dx is equal to 2 upon 3 dt. So we can write integral x power 1 by 2 dx is 2 by 3 dt. So here x power 1 by 2 dx we can write 2 upon 3 dt divided by under root of 4 minus, that is 2 square minus t square. So which is 2 by 3 under root 1 upon root of 2 square minus t square, since we know that integral 1 upon root of a square minus x square dx, which is equal to sin inverse of x upon a plus c. So we can write 2 upon 3 sin inverse of t upon 2 plus c constant. So we can write t is equal to x power 2 by 3. So 2 by 3 into sin inverse of x to the power of 3 upon 2 divided by 2 plus c is the answer. So which is our option A. So let us consider integral I is equal to 0 to pi by 2 2 power sin x upon 2 power sin x plus 2 power cos x dx. So it is 1, and let us apply the property integral 0 to f of x dx is equal to integral 0 to a f of a minus x dx. So here we can use I is equal to integral 0 to pi by 2 to the power of sine of pi by 2 minus x divided by 2 to the power sine pi by 2 minus x plus 2 to the power cos pi by 2 minus x dx. So I is equal to integral 0 to pi by 2 to the power sine pi by 2 minus x is cos x divided by 2 power cos x plus 2 power sin x. Let us consider to be this is 2 equation 2. Now adding 1 and 2, I plus I is equal to integral 0 to pi by 2. Both the integrals are limits are same, so we can add, and denominator we can see that 2 power sin x plus 2 power cos x, and here also same. So we can take 2 to the power of sin x plus 2 to the power cos x, and the numerator also we can take here 2 power sin x plus 2 power cos x. So 2 power sin x plus 2 power cos x. So both gets cancelled numerator denominator. So we have 2i is equal to integral 0 to pi by 2 1 dx. That is 2i is equal to integration of 1 is x over the limits 0 to pi by 2. So we get 2i is equal to pi by 2 minus 0, or we can get I is equal to pi by 4. So pi by 4 is the answer, which is our option C. Evaluate integral x square upon x square minus 1 dx. Let us add and subtract 1. So we can write integral x square minus 1 upon x square minus 1 plus 1 upon x square minus 1 dx. So we can separate integral 1 plus 1 upon x square minus 1 dx. So we can get integration of 1 dx plus integral 1 upon x square minus 1 square dx. So integration of 1 dx is x plus, and we know that integral 1 upon x square minus a square is equal to 1 by 2a log of x minus a upon x plus a plus c. So here we can write 1 upon 2 into 1 log of x minus 1 upon x plus 1 plus c, that is x plus 1 by 2 times log mod of x minus 1 upon x plus 1 plus c is the answer. So which is option B, option C. Option C is the answer. Find the value of integral 0 to 4 pi mod of sin x dx. And we know that mod sin x function is periodic. We can see the graph of mod sin x from 0 to pi, and again from pi to 2 pi, and again 2 pi to 3 pi, and again 3 pi to 4 pi. The graph is like periodic function. So we can say they are equal areas. So instead of 0 to 4 pi, we can add 4 times integral 0 to pi mod of sin x dx we can represent. And also we can remember as a property, integral from 0 to nt f of x dx is equal to n times integral 0 to t f of x dx, where t is the period of the function, where t is the period of f of x. So here mod sin x period is pi, so we can write it's 4 times 0 to pi mod sin x dx. And we know that in 0 to pi sin x is positive, so we can represent 0 to pi. Instead of mod sin x we can write sin x dx. 4 times integration of sin is minus cos x over the limit 0 to pi, that is 4 times 4 times minus cos pi minus of minus plus cos 0. So we can add 4 times of cos pi is 0, and here cos pi is minus 1, so minus of minus plus 1 we can write, and cos 0 is 1. So 1 plus 1 2, 2 times 4 is 8. So 8 is the answer, which is option A. Given two integrals, I1 is equal to integral 1 to 2 1 upon root of 1 square plus x square, that is 1 plus x square dx, and integral I2 is equal to 1 to 2 1 upon x dx. So here we know that integral 1 upon root of a square plus x square dx is equal to log mod of x plus root of x square plus a square plus c, and integration of here integration 1 upon x dx is log x. So both are natural logarithms, so we can take base e, and so we can write here I1 is equal to log mod of x plus root of x square plus 1 and over the limits 1 to 2, and here an I2 we can write log x over the limits 1 to 2. So we can write I1 is equal to log 2 plus root of 2 square plus 1, that is 5, minus lower limit, that is log 1 plus root of 1 square plus 1, that is 2, or we can write I1 is equal to log 2 plus root 5 divided by 1 plus root 2 by using the property log a minus log b is log a by b. So we can write log a minus log b is equal to log a by b property we can use, and which is approximately log 2 plus root 5 value can take it as 4.23 approximately, and 1 plus root 2 means 1.4 plus 1, that is 2.41. So which is approximately log of, if you do divisions you will be getting 1.76, and here we can write integral I2 log 2 minus log 1. Log 2 value is let us write log 2, and log 1 value is 0. So we got I2 value is log 2 and I1 value is 1.76. And if we see the graph of logarithm, natural logarithm, E value is 1, log E value is 1. So we can mark log E1 and log 1 is 0, and the graph can be increasing, and log 0 is not defined. So this is 1, and clearly we can say that since it is an increasing function, 2 is greater than, or 1.76 is smaller than log 2. So log of 1.76 must be smaller than log 2. So log of 1.76 means I1, your integral I1 is smaller than I2. So we can say I1 is smaller than I2, or I2 is greater than I1. So which is option B. So we can go with an option B, I2 is greater than I1. Integral 4 times cos of x plus pi by 6 into cos 2x into cos of 5 pi by 6 plus x dx. Let us use the property 2 cos A cos B which is equal to cos A plus B plus cos A minus B. So we can write integral 2 times of cos 2x into 2 cos of x plus pi by 6 into cos of x plus 5 pi by 6. So we can write integral 2 times cos 2x into cos A plus B, that is x plus pi by 6 plus x plus 5 pi by 6 plus cos of x plus pi by 6 minus x minus 5 pi by 6 dx, which is integral 2 times cos 2x cos x plus x, that is 2x, pi by 6 plus 5 pi by 6 is 6 pi by 6, that is pi, plus again cos, here pi by 6 minus 5 pi by 6 is minus 4 pi by 6, that is minus 2 pi by 3. So we can write here integral 2 cos 2x into cos pi plus theta is minus cos 2x, and again cos of negative 2 pi by 3 is cos 2 pi by 3, cos of negative 2 pi by 3, which is cos 2 pi by 3, and cos 2 pi by 3 value is cos 120 degrees, that is 90 plus 30, that is pi by 2 plus pi by 6. Cos pi by 2 plus pi by 6 is minus sin pi by 6, that is minus 1 by 2. So we can write here negative 1 by 2 dx. So integral minus 2 cos square 2x and again minus cos 2x dx. So we can write, and we know cos square theta is, we know the formula, 2 cos square theta minus 1 is equal to cos 2a. So 2 cos square theta we can write it as cos 2 theta plus 1 plus cos 2 theta, and negative is, so we can write integral minus cos 2 theta, that is minus cos 2 times of 2x minus 1, and again here minus cos 2x whole dx, that is integral minus cos 4x minus cos 2x and again minus 1 whole dx. So let us now integrate. Integration of negative or minus, you can take the whole common. Integral of cos x is sin 4x upon 4, and plus integration of cos 2x is sin 2x, and divided with the coefficient of x is 2, and integration of 1 is x plus some constant c. So negative of sin 4x upon 4 plus sin 2x upon 2 plus x plus c is the answer, which is option. So we can say the option A. So given that Im is equal to integral 1 to e log x whole power m dx, where m is a natural number, and we need to find I10 plus 10 times of I9. So let us consider I10. So in place of m we have to consider 10. So integral 1 to e log x whole to the power of 10 dx. Let us apply by parts. So since we know the differentiation of log x is 1 upon x, so let us take the first function as log x whole power 10 and the second function is 1. And we know integral fg is equal to f integral g minus integral of f dash into integral of g. So we can simplify and write here I10 is equal to f into, that is, log x whole power 10 into integration of 1 dx is x minus integral of f dash is differentiation of log x whole power 10 is 10 into log x whole to the power of 10 minus 1 9 into differentiation of log x is 1 upon x, and again integration of 1 dx is x dx. So here x and x get cancelled, so we can write x times of log x whole power 10 minus, and here we can say 10 times integral log x whole to the power of 9 dx. So log x whole to the power of 9 dx, and here the integral limits remains the same 1 to e, and here we need to substitute 1 to e. So we can say this is a, here the limits 1 to e. So x times of log x whole power 10 minus 10 times of I 9 we can write. So that I9 plus I10 this will go other side plus 10 times of I9 is equal to, substituting here the limits 1 to e, upper limit e times log e minus whole power 10 minus 1 into log 1 whole power 10, that is log e value is 1, so e into 1 power 10 minus 1 into log 1 is 0, 0 power 10 is 0, so we can write e. So I10 plus 10 times of I9 is equal to, so we can go with an option only e, which is option C. C is the answer. E is the answer. Given that integral 2 cos x minus sin x plus lambda upon cos x plus sin x minus 2 dx is equal to a times log of mod cos x plus sin x minus 2 plus bx plus c, then the order triplet a comma b comma lambda is. So let us go with the verification by differentiating the right side. So d by dx of a times of log mod of cos x plus sin x minus 2 plus bx plus c is equal to, so we can write a into differentiation of log is 1 upon cos x plus sin x minus 2 into differentiating cos x is minus sin x plus cos sin x differentiation is cos x and constant is 0, and again plus b times of x is 1, differentiation of x is 1 plus differentiation of c is 0. So we can simplify and write here a times minus sin x plus cos x upon cos x plus sin x minus 2, and here we can write b times of cos x plus sin x minus 2. So we can take coefficient of cos x will be a plus b of cos x, and coefficient of sin x we can write minus a plus b of sin x, and the constant remains here minus 2b divided by cos x plus sin x minus 2. So when comparing both the sides, so we can say a plus b is equal to 2 and minus a plus b, which is equal to negative 1, and we can say 2b is equal to minus lambda. So by solving these two equations, we'll get 2b is equal to, by adding this both equation, so b is equal to half, and when b is equal to half, so a is equal to 2 minus b, that is 2 minus half, that is 3 by 2. So the value of a is 3 by 2, and lambda value you can get minus 2 times of b, that is 2 into 1 by 2, so lambda is minus 1. So a value is 3 by 2 order triplet, and b value is 1 by 2, and lambda value is minus 1. So 3 upon 2, 1 upon 2, and minus 1, which is option B. So option B is the answer. Evaluate integral x into tan inverse x dx. So let us apply by parts. Inverse function, let us take the first function and the second function algebraic function. And we know integration fg is equal to f into integration of g minus integral of f dash into integral of g. So we can write f into, that is tan inverse x, into integration of x dx minus integral of differentiation of tan inverse x into integration of x dx, the whole dx, that is tan inverse x into integration of x is x square by 2 minus differentiation of tan inverse x is 1 by 1 plus x square into x square upon 2 dx. So we can write x square upon 2 tan inverse x minus 1 upon 2 integration of x square upon 1 plus x square, here adding and subtracting plus 1 and minus 1 dx. So we get x square upon 2 tan inverse x minus 1 upon 2 times of integral x square plus 1 upon x square plus 1 minus 1 upon 1 plus x square dx. So here x square plus 1 gets cancelled. So we can write x square upon 2 tan inverse of x minus 1 upon 2 integration of 1 dx is x minus integration of 1 upon 1 plus x is tan inverse of x plus constant c. So we can write x square upon 2 tan inverse x minus x upon 2 plus 1 upon 2 tan inverse x plus constant, or we can take tan inverse x common. So x square plus 1 upon 2 of tan inverse x minus x upon 2 plus c is the answer. So we can go with an option. So first option is satisfying. So first option is the answer. Option A. Evaluate integral 0 to 1 dx upon root of 2 minus x square. So we can write 2 minus x square as root 2 whole square minus x square dx. And we know that integral 1 upon root of a square minus x square dx is equal to sine inverse x upon a plus c. So here we can write sine inverse x upon root 2 over the limits 0 to 1. So here we can write sine inverse of 1 upon root 2 is upper limit minus sine inverse of 0 upon root 2. So sine inverse 1 by root 2 is pi by 4, sine pi by 4 is 1 by root 2, and 0 upon root 2 is 0, sine 0 is 0. So we can say pi by 4 is the answer, which is option A.